An electric motor converts electricity into motion. This is achieved through the use of magnetic and electromagnetic fields. It is probably already in your knowledge that when two magnets are placed near each other, they will either attract each other in the case that they have opposite polarity, or repel each other if their polarity is the same. An electromagnetic field is a magnetic field that is generated by the movement of electricity. Where there is a current moving through something, there is a magnetic field that is generated outside of the object in which the current is moving. Humans have utilized this in a large portion of their technologies and equipment in what has been titled an electromagnet. Electromagnets act as magnets only when electric current is passing through them. The polarity of an electromagnet depends on the direction of the current passing through it. Electric motors utilize electromagnetic fields inside another magnetic field in order to create motion. Whether this field is a regular magnetic field or another electromagnetic field depends on the motor. To determine the direction of this motion, some people do this awkward thing with their hands, but let's be honest, it's easier to think about when it's not hands. In place of the hands, here is a basic two-dimensional representation of 3 dimensions. When an electric current, positive in this direction, passes through a magnetic field, north in this direction, the kinetic force will be in this direction. The motor case has permanent magnets encasing the rotor. These magnets are usually semicircular and sometimes circular, both sharing the similarity that one of the inward-facing sides will be the magnet's north pole and the other side will be the south, as is necessary to create the magnetic field for the production of movement from the electric current. There are points on the rotor that make contact with the power source are called commutators. They make contact through brushes on the case of the motor. The brushes are wired to the power source. The circuit is completed on the rotor, meaning that the point of contact will always change to generate a magnetic field the same as the outer case magnet closest to the electromagnets on the rotor, repelling it away from the closest magnet and attracting it to the magnet on the opposite side, rotating the rotor to face the other direction. The electric current would then flow in the opposite direction in relation to the rotor, because the brush is now contacting that side, again repelling it from the current position and attracting it to the next. So the axle will continue to rotate in the same direction until electric current is no longer flowing through the wire. This is a segment of a computer fan. It is slightly different from what I just explained, as the outer magnets rotate around the electromagnets, rather than the electromagnets being part of the rotor. This negates the need for brushes, however this means that the electromagnets need to switch their polarity in time with the rotation of the fan. The computer can also control the speed of this fan by changing the rate that the electromagnets switch polarity.